All right, let's jump right in. When we picture industries like oil and gas, we tend to think of it as this purely mechanical world, all steel and pipes. But what if I told you these facilities have a kind of circulatory system, a beating heart that can actually get sick, a lot like we can? Today, we're basically putting on our lab coats to diagnose a surprisingly common and costly industrial illness.
And that's a huge question, right? Because when this heart starts to fail, the entire system just slows to a crawl. It gets super inefficient and the costs start piling up like you wouldn't believe. This isn't just about a piece of machinery breaking down, it's really about the overall health of the entire operation.
So let's go ahead and meet our patient. The industrial heartbeat of countless processing plants isn't a pump, like you might think. It's actually something called a heat exchanger.
Yeah. You can think of these things as the hardest working organs in the entire plant. Their one, absolutely critical job is to move heat from one fluid to another, and they do it nonstop, 24/7. They're essential for making sure every single process is running at just the right temperature.
But here's the problem. Just like the arteries in our own bodies, these vital systems can get clogged. So let's move on to the diagnosis. We need to identify the specific illness that plagues these industrial pipelines. And that illness has a name: fouling. Honestly, the best way to think of it is as industrial cholesterol. It's just a buildup of unwanted gunk on the inside of these vital components that slowly but surely chokes the life out of the whole system. And this sickness doesn't just come from one single place either. It could be mineral scale from hard water, sort of like what you see in a kettle. It could be slimy biological growth, rust and other corrosion, thick and oily hydrocarbon deposits, or even just tiny little bits of sand and grit. All of these things can create a serious blockage. So, what actually happens when fouling really takes hold? Well, let's look at the symptoms. Because just like a real illness, the signs are totally clear if you know what you're looking for, and the consequences can be pretty severe. And wow, the difference is just night and day. On the left, you've got a healthy system. Everything's flowing freely, efficiency is high, and the equipment lasts a long time. But on the right, that's our sick patient. Flow is restricted, efficiency is plummeted, operating costs are through the roof, and you're facing the very real risk of a complete, unplanned shutdown. It's a huge problem. Okay, but here's the good news. This is a treatable condition. There is a cure. So let's talk about the cleaning procedure, which is a lot like a doctor prescribing the right medical treatment for our industrial patient. Now, the treatments vary depending on how bad the case is. For a mild case, you might do a circulation cleaning, which is kind of like putting the system on a bypass machine to flush everything out. For more serious clogs, there's a fill and soak method. And for the most stubborn, toughest blockages, you gotta bring in the heavy-duty tools, like high-pressure washing. You see, the pros don't just guess what to do. They follow a very clear, almost medical process. First comes a thorough diagnosis, where they analyze exactly what the blockage is made of. Then, they write a prescription, selecting the perfect chemical formula for the job. After that, they administer the treatment, and, most importantly, they follow up with a verification step to make sure the patient is back to 100% health. So, what's actually in these prescriptions? What's the medicine? Let's take a peek inside the industrial pharmacy to see the powerful chemicals they use to cure fouling. It's a pretty specialized toolkit. You have your acid-base cleaners, which are these powerful solvents that just dissolve hard mineral scale. Then you have alkaline cleaners, and their job is to cut through all the grease and oily organic gunk. And then you've got something called chelating agents. Think of these as the gentler, more targeted medicines for sensitive systems where a really harsh approach might do more harm than good. Of course, curing the illness is great, but preventing it from ever happening in the first place, that's even better. And that brings us to our final, and maybe most important step, creating a long-term health plan for our equipment. Because really, long-term health requires a kind of lifestyle change for the system. That means doing things like proactive water treatment, which is like its healthy diet, optimizing how it runs, using preventative medicines like antifoulants, and of course, scheduling regular health checkups to catch any little problems before they become big ones. And hey, don't just take my word for it. Industry research totally backs this up. It's not about a one-time fix, it's about having a complete, comprehensive strategy. That's how you get peak performance and a long, productive life out of these industrial hearts. So, if you remember just one thing from all of this, let it be this. Prevention is always the best medicine.
And that's true whether we're talking about our own bodies or the massive industrial systems that power our modern world. An ounce of prevention is worth a pound of cure. It really makes you think, though, doesn't it? Beyond what we see every day, what other complex, absolutely vital systems are working silently behind the scenes to keep everything running? And more importantly, what does it take to keep them healthy? It's definitely something to think about.